Sir, up to six alphabets, it was easy. Rather than it was little bit confusion, sir.
Where, madam, you could have try and you could have sent me the picture, no, so that I could have clarify your doubts, I think. Actually, we have discussed till yesterday in the class, we have discussed till where there are some elements, no, H, I, J, B, A. If the confusion is there, then you could have asked me by sending your picture so that after installing, after inserting this element, I am getting this one. I am unable to balance it. So please help. You could have sent the picture, no? If I could have clarified your doubts. No, it's up to you. I said it's very important one.
Yes,
It's
sir.
up to you.
I tried that one.
Sorry, madam.
I tried that one, sir. Up to A, you have told in yesterday's class.
No problem. After the class also you can send. I'll be free to help you guys at any time.
Okay, sir.
So it's up to you. And here it is not the thing to like spoon feeding. So you are a final year students and you are a graduates. You are well matured. And if someone said it is important, you need to take care about that. And if we concentrate on only particular, this is the fourth day actually. If you stick on to particular topic, then we won't cover many more topics. There are many more topics to be covered. Hashing is there, hash tables are there, and graphs are there, and more trees are there, and this what you call this one sortings are there. Two types of sorting 1 and sorting 2 are there, and more this linear data structure like stack, queue, linked lists are there. These are very, very important. Okay, friends, it's up to you. No, I don't want to discuss more about this AVL trees topic because if you complete that question, whatever we have discussed yesterday and day before yesterday, that's more than enough uh, to understand the concept. And if you want to practice, I have given that example. That is more important. So you concentrate on that. If you have any doubt, you can send me the picture and you can ask where you are really stacking up. So now I want to move to the topic, the basic topic of first block, the linear data structures. Let me share my screen. Is it visible to you?
Yes, sir. Yes, sir.
What you can see?
Paint.
Sorry? Paint, right?
Paint, sir.
Yeah, paint. Okay. We will see like linear data structure. We have discussed what do you mean by linear data structures and what do you mean by data structure and in the first class. What do you mean by linear data structure? In the linear data structure is a type of data structure in which the elements are arranged in a sequence manner, in a line manner. Like you can arrange the elements in the sequence one by one. Like its example is array. If you know the topic about array, so that will be the best example for linear arrangements of elements. So the linear data structure is a type of data structure in which you can store the elements in the sequence. We have various types of linear data structures, and they are first one is arrays. Second one is stack. Third one is queue. Fourth one is lists. Linked list you can say. So what do you mean by array? An array is a data structure. It will store the elements in a sequence order. That is one definition. You can define in another way. An array is a data structure, or an array is a variable that can store elements of similar elements of same data type. Multiple elements of same data type. An array is a data structure that can store multiple elements of same data type. Same data type is important topic here. Example, if you declare an array like same data type int a of 10, that means instead of storing one by one elements in different variables, if you want to store 10 elements in the memory, you need to take 10 variables. But if you want to store the marks of the students of 10 marks of 10 different students, you can declare a single variable a by declaring its data type. Here, what do you mean by this int a of 10? Means you can store maximum of 10 elements in the array called a, that all the elements are belongs to only integer type. This is sequence order, like this is a 1, 2, 3, 4, 5, 6, 7, 8. Indices. It starts from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Till 9 it will be there. That means that you can store multiple elements that are belongs to same data type. Here you can store only integers. The indices starts from 0 to 9. Another example, float of A15. That means you can store only decimal numbers in the array. The maximum numbers you can store is 15. That is what. This is about array. And we need to focus on only the stack, queues, and linked list. I'll discuss about stack. If you have any doubt in the meanwhile, please you may disturb me and you can ask. Stack data structure. Is it visible?
Yes, sir.
Yeah. What do you mean by stack data structure? You have discussed already. You know something about stack, about you came to know in the class. This practical class we have discussed. So how can you define a stack? A stack is a linear data structure that follows the property or principle or the rule of last in, first out. Or you can define in different way that a stack is a data structure based on the principle last in, first out. You can define various ways. Whatever is convenient for you, you can define in that particular way. I'll write it on here. It is very, very important. Stack is a data structure LIF. You please go through this statement and definition. A stack is a data structure based on the principle or property or criteria, whatever the word you can use, which is convenient to you. And the main thing is, it is based on the property last in, first out. Whatever the element you insert at the last, that will be taken out for as a first element. Like I'll share some picture. Can you see this picture on the screen?
Yes, sir.
Yeah. Here there are some elements. This one, this is called a stack. This is an example of stack data structure. This you will insert first. This is second, this is third, and this is fourth, and this is fifth, and this is sixth. And you can take this is like a rack of the CDs, compact disc, if you see that multiple CDs, which is to a particular rack or a bundle, you can't take out the element which is inserted for the first time. So whatever you insert at the last element, this will be taken out first. Then this will be taken out the second. Then this will be taken out the second. Then third, fourth, fifth, sixth. Like whatever you insert for the first element, that will be last. First insert చేసింది last తీస్తాము, last insert చేసింది first తీస్తాము. This is the property of stack. And you may ask this question in the exam like, what do you mean by a stack data structure? Explain about the stack data structure. And what are the properties of, what are the operations you can done on the stack data structure? And what are the various applications of stack data structure in the real time? So you can, if you know that word, the principle last in first out, or first in last out also, you can write FIFO or LIFO. Last in first out. The principle. You can take some other example like can you see this now?
Yes, sir.
Yeah, this is what the empty stack, the first one. This one we can change the color of the, this is the empty one. And if you want to insert the first one, the insertion operation will be called as push. And the removing the elements, removing operation or deleting operation will be called as pop. This is insertion is nothing but push, and the deleting or removing is nothing but pop. This is empty stack. So nothing has been inserted. And if you want to insert the first element into the stack, you need to push. The first element is here. That is 1. This is 1 is inserted. And next 2 is inserted here. Next 3 is inserted. So here in this picture, which element is inserted at the end? Means at the last.
3.
Yes, exactly. So 3 is the last element. We have inserted 3 elements one by one. 1 is inserted first, and 2 is inserted next, and 3 is inserted at the end. So in order to get that 1, if you want to take out 1, if you want to remove 1, if you want to delete 1 from the stack, you need to delete all the elements which are above to that 1. So first you need to remove this 3. Then you need to remove this 2. Then only you can remove this 1. Is it correct?
Yes, sir. Yes, sir.
Yeah. This is what the operations can be done on stack. And you need to define the stack size based on your requirement. Suppose if you want to insert 10 elements, and you can take the size of stack as 10. So you can insert one by one element, 10 elements into the stack. Only maximum size you can define, but you can store only based on the stack size, you can insert the elements. If you take stack size as 15, your possibility is to insert only 15 elements. You can't insert more than that. The two operations, the inserting operation is nothing but push. This is called insert. And pop is to remove or delete the elements. This is deletion or removing, both are same. You got it, friends? Got it or not? Any doubt?
Yes, sir.
Yeah. So we will see the operations. What are the various operations are there on stack? So the question will be, what do you mean by stack data structure? And explain what are the various operations on stack. Operations can be performed on stack with some example. So what are the operations can be done? As you know, what are the operations according to you? One is insertion operation, one is deletion operation. Insertion operation is nothing but push, and deletion operation is nothing but pop.
Pop.
Is there any other operations? The question is very important one. The question may come for 10 marks.
Peak.
Peak, sir.
Sorry?
Peak.
Peak.
Please, you speak somewhat louder.
Peak, sir.
Can you spell it out?
P-double-E-K.
What do you mean by that?
To see topmost
Means,
elements.
say the topmost elements.
What is the need? What is the need to see the topmost element?
It is used to deletion or insertion of another element, sir.
Is it correct? The word you said, you speak it is okay. But the clarification what you are giving is not that much satisfactory. Okay, let me discuss about what are the various operations, different operations can be, operations or actions you may call, can be performed on stack. First one is push. Second one is pop.
Pop.
Third one is, this is a function actually. So for all the functions, you need to use the parenthesis at the end. Push. If you write something inside the braces, that element will be inserted into the stack. Push, pop, and anything else, only these three, these two. Is empty. I have discussed in the class also. I don't know whether you are there on the time or not. Is empty and
Is full.
is full. And the last one, as you discussed, this is called peak. So what do you mean by these operations and what is the purpose of these operations? Push is to insert an element into the stack. Can you tell about this pop?
Remove item
Yeah,
element.
to delete.
Topmost element.
Exactly. To delete the topmost element, not other elements. You need to specify specifically the word top. Topmost element from the stack.
Hmm.
What about E is empty? What is the necessity?
Maybe we need to check it is empty or full. I think so.
When it is necessary, madam?
After seeing the stack,
No. When you will check this one, E is empty.
To insert an element.
before
No.
before running the operation.
What is the need of running?
Hmm.
No, before doing something, you should have some clarification on that. What is the need of doing this operation? Is empty is necessary operation in order to pop an element. See,
Tell once again, sir.
sorry,
Tell once again.
is empty is an operation which is to be performed necessarily before popping an element from the stack. Let me clarify with an example. We'll take this one. Can you see this picture here, friends?
Yes, sir.
What is the first one here?
Empty stack.
Empty stack. You ignore the remaining images. You keep
Okay.
it in mind that only the empty stack. Can you pop any element from this empty stack?
No.
Can you? What happened?
No, sir.
Can you stack something from the empty stack? Can you pop? Because there are no elements to be popped.
Pop or push.
So there are no elements to be removed from the stack. So in that
Hmm.
case, you can't delete any element from the stack because no element is there to remove. So in that case, you will get some error because there are no elements to remove from the stack. So it is not possible to remove. So that error may occur. Due to this error,
Hmm.
to avoid this type of errors, you need to check whether the stack is empty or not before removing. If it is empty, then you can't remove any element. No, because there are no elements to remove.
Yes.
So this is what is empty operation should be performed before removing any element from the stack. Getting my point, friends?
Yes.
Yes, sir.
Yeah, if it is empty, then you can't remove any element. So that is why before removing or before popping up any element from the stack, you need to check. You need to make sure that
It is empty or not.
yeah, it is an empty or not. If it is empty, if you use this operation, that
We will
will
get error.
no. If it is even if it is empty, although you are trying to remove some element, then only you'll get some error.
Huh.
No, in the program, you need to check whether it is empty or not. If it is empty, simply you can display that there are no elements to be removed from the stack.
Got it.
Got my point?
Yes, sir.
That is what empty. Is empty operation should be performed before popping up any element from the stack. If the stack is empty already, then you can, if you check this operation is empty, if the stack is empty, then you can display that stack is empty. There are no elements in the stack. So pop is not possible. Removing is not possible. If it is already empty and again you are trying to pop up, then you'll get the error. To avoid those type of errors, you need to check whether stack is empty or not. Based on this operation, you'll come to know whether it is empty or not. If it is empty, you can simply display that the stack is empty, no more elements to be removed from the stack. Got it, friends?
Yes, sir.
Then is
Full.
you can write if you want about this one.
Okay. Yes, and
To be checked before removing an element from the stack. Here you can write, if the stack is empty, then we cannot remove any element from the stack. This is what you need to write. This one.
Hmm.
Okay. This is empty is related to which of the above two operations? Is empty is related to pop or push.
pop.
Pop only.
Hmm.
This is related to this one.
Pop.
And this is related to
Push.
this one. So can you explain about this one? Is full. How it is related to this one?
It is checked before insertion.
Can I erase what is appearing on the screen?
Yes, sir.
Or else I remove this one. Only this line. I'll go with this one. See, you have the stack size is only 3. That means you can insert only 3 elements max in the stack. You have
Yes.
inserted 2 here. You have inserted 3. You have inserted 5. The stack is full now. Is it possible to insert one more element in this stack?
No.
No,
Why?
sir.
Why?
There is no place.
Exactly. There is no space in the memory.
The tag is full.
Yeah. That's why before inserting some element into the stack, you
Yeah,
need to make sure that whether it is full or not.
Hmm. Hmm.
If it is full, then you can display that stack is already full. We are
Hmm.
unable to insert elements into the stack.
Got it.
Got it, friends?
Yes, sir.
Yeah. I'll take one more example here. That's the same example. Now you can see the stack. Can you insert any element into the stack?
Yes.
How many?
Yes, sir.
One.
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 So if you apply this action or operation before inserting some element into the stack, you need to check whether stack is full or not.
Hmm.
If you apply this is full operation on this existing stack, whatever you are looking on the screen,
Hmm.
what it will display? Is it full or not?
It is not full.
Yeah, that's what. If you apply this operation on this stack is full, it will reply that no.
No, it is
No
not
means
full. Push an element.
yes, you can insert one element. Before inserting every element, you need to perform this operation. See, friends, you have two more elements to be inserted, like you have 5 and 6. Now,
Hmm.
you don't know how much space is there in the stack.
Hmm.
That is there hidden inside the memory. Before inserting 5, you will check is full. It will reply you as no. Then you can insert this 5 into the stack, and you will insert 5 into the stack, and the stack will be full. You don't know whether stack is full or not.
Hmm.
Before inserting this 6, you will check this operation. Is full?
Yes. Yes, it's
What
full.
is the reply you are going to get?
Yes,
Yes.
it is full.
Yes, it is full. Can you insert 6 now?
No.
No.
No. This is what. So before inserting any element, every element, even for the first element also, you take this example, this one. This one, you have the elements like 2, 3, 4, 5.
Hmm.
You have not started the insertion operation or pushing the elements into the stack. You can check whether the stack is full or not. What you reply you will get according to the picture what you see on the screen.
We have space in stack, we can.
No, it will reply.
Okay.
Your question is full.
No.
No.
No means you can
You can put
insert
anything.
one element. This will go here. 2 is inserted. Again, you need to insert one more element, 3. Again, you
Again,
will perform this
repeat.
is full. Your answer will be
No.
no. No means you can insert
3.
Again, you will perform this is full.
No.
No means you can insert 4.
4.
Again, you perform the same operation.
It is full? No.
Is full.
Yes, yes.
Yes, it
Yes.
is.
full.
Yes. So you have inserted this 2, 3, 4, and there is no space for the last element 5. So in this case, you need to take the action whether you need to increase the size of the stack or you need to define one more stack. That depends on the situation. The thing
So
is,
we can do like that, sir. We can increase the stack if we have elements more.
yes, you can.
2, 3, 4, 5, and more 2, 3. I have more 3 like 6, 7.
This is actually the programmatically you have to be done in the. This is only the concept to understand how this can be performed. The actually implementation will be done using a program. So
Okay.
in the program, you need to increase the size of the stack by increasing a number.
Oh.
So that is not difficult or not rocket science. Only you need to change the size of the stack.
Size of the stack. Okay.
So that thing is what I want you to know is before pushing any element into the stack, you need to check whether the stack is full or not. If it is full, then you can say that the stack is already full, then we can't insert any element into the stack.
Okay.
So how can you explain this one? Is full. This operation is to be checked before inserting any element into the stack. If the stack is full, then we can say that we can't insert any element into the stack. If the operation is full, replace you as no, that means that stack is having some space so that you can insert or you can push one more element into the stack. Got it?
Yes, sir.
Any doubt?
No.
Now we will see what do you mean by peak. This peak operation, that is, what do you think about this peak operation? I think you said
To view topmost element.
to view.
Topmost element of the stack.
Exactly. To view
Maybe
the
values
topmost.
of.
Exactly, the value. Peak is the operation used to. This operation is used to get
The value of topmost element.
the value of topmost element without removing it. Without removing it. Can you explain these operations with some examples? So let me know. You have clarity on these 5 operations now. What do you mean by push? What do you mean by pop? What do you mean by is empty? When it should be applied? What do you mean by is full? When it is necessary? What do you mean by peak? Are you aware of these operations now?
Yes, sir.
Only Joha?
Yes, sir. Yes, sir.
Okay. I'll let you know how to explain these operations if you get only what do you mean by stack data structure, explain about various operations of stack. Let me see. If you take the example like push, how should you write in the exam LDL? Push is the operation performed on stack data structure to insert elements into the stack. Clear?
Sir.
Can you repeat once again?
Push is the operation which is performed on the stack data structure to insert elements into the stack. Example, you need to write each and every example for each and every operation. Example, if you want to insert 1, 2, 3 into the stack size is like this, empty stack. The first operation is inserting 1. So 1 will be here. Next, inserting 2. Already 1 is there here. 2 will come. Next, inserting 3. 1 is there, 2 is there, 3 is there. Here we are inserting 3. Got it?
Yes, sir.
You need to
Yes,
take
sir.
the small example. You need to start with the empty stack before pushing. First element will come, second element will come, and third element will come. Can you write this definition and can
Yes.
you write this example in the exam?
Yes.
If you
Yes,
get
sir.
this question.
Yes, sir.
Yeah, we
Sir,
will see.
you
Yeah,
to
please.
repeat once again the definition of push.
Stack push is an operation
Hmm.
to be performed on stack data structure to insert elements into the stack. Next, we will see about pop. This is an operation of stack data structure used to remove elements from the top of the stack. Pop is an operation of stack data structure used to remove the topmost element of the stack. Got it?
Yes, sir.
Example we will see.
Sir.
The same example, in the previous example, in the push, we have taken 3 elements, no? Consider you have the 3 elements in the stack. The first element is 1 and second element is 2 and third element is 3. This is the stack. This is or full or something, it's whatever. This is the stack. To remove 3, this is 1, this is 2. And now
Next
3
step.
will go out. This is pop. Next, only 1 will come. This 2 will go out. Next, empty stack will be there. 1 will go out. Got it or not?
Yes, sir.
The picture will speak on behalf of your answer with the evaluator. Whatever the content you write in terms of text will not affect greater than this one. These pictures will speak. By looking this picture, the examiner or evaluator will come to know this fellow knows about this operation well. So there are elements in the stack and they have removed one by one. That means the pop operation is done. Clear?
Yes, sir.
Next, you can write about
Yes,
next
sir.
operation is empty. What will you write? Already I have given the notes on the screen a few minutes ago. I have written with my own hands and I have discussed also. What will you answer? Is empty.
To be checked before removing.
Is empty
Before
is
passing an element.
Yeah, is empty is an operation of stack data structure which should be performed before
For removing an element from the stock,
exactly.
if the stock is empty, we cannot remove any element from the stack.
Exactly. Thank you. Any more information? This operation is necessary before removing elements from the stack because if the stack is empty and although you are trying to remove some element from the stack, you will get some error. The stack is empty, although again you are trying to remove some element from the stack. No elements are there in the stack, then how can you remove it? So in that case, you'll get the error. So to avoid those type of errors, you need to check whether the stack is empty or not. If you perform that operation is empty, if the stack is empty, that will reply you it is empty, so that you won't try to remove any element. If you get the reply as no, means is empty, your reply is no, your system reply for you is no, that means that you have some elements in the stack, you can perform the pop operation. We'll see some example. Is empty. Example only we'll see. This is empty stack. You are trying to remove some element from the stack. What you get it? Error.
Error.
And is empty operation will perform. You have one element in this. You write is empty. What is your answer? What is your system's answer to you?
No.
No. Your answer is no. So that you can pop one the stack. Got it or not?
Yes.
If it is empty,
Yes.
again you are trying to pop, you'll get error. If is empty operation replace you as no, that means that you have some elements in the stack.
We need to
You
pop
can
it out.
Yeah, you can simply pop up those elements from the stack. These examples you can simply write in the exam if you get this one. Can I move forward?
Yes. Yes.
Thank you. Yeah. Is full. What's your answer to this?
We need to check if the elements are full. If we
No,
run the
you have to
operation.
start like, please.
Okay.
This is an operation of stack data structure
This is
which should be performed before pushing an element into the stack. Because if you are going to insert or push some element into the stack, even if the stack is full, then you'll get some error. Example, you have the stack size is 3, 5, this is 6. Is it full or not?
full.
Yeah. If you apply this operation on this, is full. What is your system's reply to you?
Full.
Yes or no?
Yes.
Is full? Yes.
Yes.
That means that you can't insert any element into the stack. You can write this one. Is full? Yes.
Yes.
In this case, we cannot insert
Any element.
any element into the stack.
This stack.
Next, you take one more example. You have only 3 and 5 here. You have some space here. Now you perform this one. E is full.
No.
No. Means stack is not full. And in
We
this
can,
case,
we can push an element.
yes, exactly. In this case,
In
we
this case,
can
we
push
can push or insert
an element into the stack. You can write, you can use only push because
Okay.
stack data structure, no. Or
Okay.
simply you can use insert also, no issue. You can push an element
Use,
into the stack. Got it, friends?
Yes, sir.
Yes, sir.
This you need to write in the exam. Can I move?
Yes, sir.
Yeah.
Yes, sir. Speak.
What is the next one?
Speak
Peak operation.
the value of topmost element without removing
Yeah.
it.
This is an operation of stack data structure. Use it to view or get or see the topmost element, the value of topmost element, or simply the element, the topmost element from the stack without removing it. So we have only two operations. Main operation on the stack is push and pop. Those two are the main operations.
What's the formula?
Sorry?
Once again, tell the formula, definition of speak.
No, you know, no. Whatever you know, you can write. You have.
Okay.
This is an operation of stack data structure. Use it to view the topmost element of the stack without removing it. You can define in different way. Peek is an operation of stack to get the topmost element from the stack without removing the value. We can see example, you have 4, 10, 11 and 15. If you apply this peek, your answer will be 15. You can write after peek operation. Will it remove any elements?
No.
No. After peek operation also, you can write the elements like 4, 10, 11, whatever you take. For example, this is what. Peek will display only the topmost element in front of you. It will not remove any value. That is what. Clear, friends, these 5 operations?
Yes.
Sir.
Yes, sir.
Yeah, fine. So you need to write about the what do you mean by stack data structure? What are the various operations can be performed on stack data structure? And more information you need to write about like
Stack operation.
no applications of stack data structure. This is important, friends. So you need to define stack data structure. What do you mean by stack data structure? A stack is a data structure, or simply a stack is a linear data structure used to insert elements in the sequential order by using a principle called last in, first out. You should underline that word in the exam. Last in, first out. In the bracket, you can write LIFO. Stack is a data structure which is based on the property or principle or a criteria called last in, first out LIFO. Okay. What are the applications of stack data structure? Can you say?
Applications like push, pop, this.
Where you can use it actually? Example, if I want to know, if I want to reverse some word, like if I take the word Joha, how can I reverse the word? How the system knows that based on my operation, if I want to reverse the word Joha, how that system can reverse this word like this one? How this computer knows?
By program.
The program, whatever you write for this one, the implementation, the one of the application of the stack data structure is reversing a word. Example, see, if you take this one, reversing a word. How can be done? You take a stack. What are the letters of this word? Z, O, H, A. First you insert one by one. Z, O, H, A. Right? This one.
Right,
Insertion.
sir.
Okay. You pop up the elements one by one. Which element will be popped first?
A.
A. Next H. Next O. Next Z. Is it the same?
Yes.
Yes,
So in
sir.
order to get the reverse of any word, you can use stack data structure. You insert all the letters into the stack and you can pop one by one so that you'll get the reverse of that particular word. So
Okay, sir.
this is one application. So the applications of stack data structure is reversing a word. You can explain this one, how this process can be done. This example you can explain. And the next one, there is an important software, an important program called compilers. If you write any program, that program should be checked by another program called compiler and interpreter. If you write a program in C, C++, or Java, or Python, or HTML, or any other thing, there should be something, there should be some other program to check the program which you have written is correct or not. If you write a C program, you don't know whether the program is correct or not. If you give to a person, that person will check and he will tell whether it is correct or not, even though there may be some errors. So in order to remove or overcome those type of errors, there should be a program. That program is called compiler or interpreter. Compiler will take the entire program and that will check all the errors in the program and that will let you know whether is there any errors are there or not. So there should be some calculations. Compiler will take each and everything in the program that will gives you some errors if is there any. If there are no errors, then your program will be executed correctly. So you can write one more application is like compilers. Compiler is nothing but a program to check other programs. In compiler, stack will be used. Stack used to calculate the operations. Example, if you have like 3 plus 4 into 6 divided by 7. These type of operations. Compiler uses stack data structure. And one more application of the stack data structure is, browser, Chrome,
Yes,
Edge,
sir.
Mozilla, all this. How can you save all the URLs?
How
See,
can you?
save all the URLs. See, if I visit facebook.com,
Hmm.
if I want to save that URL, or else if I want to save, if I search for something about artificial intelligence,
Hmm.
and that is very much pretty interesting. If I want to save that particular URL,
We need to bookmark it.
that's how that can be done. You need to bookmark it. So
Hmm.
this one, you no need to visit each and every time. Simply you can come to the system and simply you can click on that link.
Hmm.
So for this purpose also, this stack will be used. Using that stack only, all that operation can be performed. You simply making the bookmarks, no? The behind that is stack data structure is there. So you can write the applications of the stack are reverse a word, and in the compilers to calculate expressions, stack will be used. And for the browsers to save the URLs, in order to access it early, the stack will be implemented.
Hmm.
These are the some operations, some applications of stack data structure. So see, I wanted to discuss about stack, queues, and linked list today, but
2 minutes
Uh,
left.
due due to lack of the time, we have discussed only stack. And if we have actually the class is only from 5th May to 11th May, but due to the weather conditions and this electricity problems, we missed 2 classes. This is the 4th class. I'll request the concerned people if they schedule any other class for us, 2 more classes. I'll let you know in the group. And
Okay,
if I
sir.
say any time, please be ready to participate in the class.
Sir, also you share no, so that we can. I wanted to run it in the laptop. This stack push pop is so
No,
in.
for that you need to write a lengthy program, Joha.
Uh,
No, as of now, your exams are very soon. No, you concentrate on this theory part.
okay.
Sir, excuse me, sir.
Sorry,
Sir, phone number may not in the group, sir.
you want number?
मेरा
Hello?
number. हाँ न sir number sir.
Take it. They may close the session. Note it down fast.
Tell me sir.
You see in the chart.
No sir, not.
Take a screenshot fast.
8885-801-804.
Sir, thank you sir.
Mute yourself, please. It is 8885-801-804. You need to text and you need to specify your admission number. Then only we will add to the concerned group. Note it down.
Yes sir, thank you sir.
Yeah. I think it's time to close. They may close at any time.
Thank you so much, sir.
Yeah. Okay, Joha. Fine.
Bye.
Guys, you may leave now.
Okay.
Yes, sir.